We are going to be talking about electrical stuff and making making good connections, doing your own electrical work without trying to burn up your battery. I recently was working on my boat and managed to short out my battery, which was painful. And we still don't know the full extent of the damage, but we're exploring that.
Wow.
So it's good to have an electrician available to consult. Bob's helped me for 20 years now, more than that probably. And he's a great guy. So Bob, without further ado, come on up.
All right. Who's a good place for me to stand or everybody?
I'm sorry. Yeah, I mean, you're visible there.
Perfect.
Basic,
Right.
you can see yourself, you can always check, but like, yeah, that's where you're visible. So,
Okay, okay. Thank you very much.
talk to them about it, feel like you're gonna talk to them.
It's very nice to meet you guys, and I feel honored to be asked to talk with you because it's really nice to be in a room full of people that we all share a love of the water, Puget Sound, sailing. That's kind of how I got into this game. My first boat, my best friend Greg Spiker and I built. We were 10, and we broke all the styrofoam off my dad's floating lounge chair that used to be in the pool. And we put it in between two pallets. We stripped all the telephone wire out of the construction site that was down the street, and we tied it together, and we paddled it across the intercoastal in Fort Lauderdale over to Burt State Park to beat the 50-cent entrance fee.
All worth it.
And I haven't looked back. We tied that boat up really tight, and then we went and played in the park, being 10-year-olds, and we came back and we were so sad when we got back, it was gone. I still feel guilty about whoever hit that. It was out there in the intercoastal. But let's see. I'm standing in a room full of people who knowingly chose 2 or 3 holes, which I find unique and amazing. I've been impressed by multi-hull, but all the boats that I've had, Hallberg Rossi Rasmus, Islander 29, I've always been a monohull guy, and always kind of jealous that your drinks like don't slide cockpit as much as the monohulls. So that's
a monomoran in this room. You want a monomoran.
monomoran. Okay, all right, good to know. All right, so the overall thing that I want to get through to everybody is that there's many paths to success to get some of this gear to run. But there's best practices that are really a good idea to adhere to, get as close as you can. And the reason why I say that is I've worked as a professional mariner and a marine electrician for a long time. I work on a boat called Dozer. It's a 120 Broward. And it was an electrically involved fire. And we were 30 miles offshore. And it was just a time where, I said to myself, like, they're not paying me enough to do this. And I really want to get back to see my wife. And where's the fire extinguisher? I should have had that in reverse order, but that's the way it went down in my head. And what it was is like an air handler that's in houses and stuff, basically just a motor with a scroll cage, was in the engine room up against the ceiling. So the other ones, there were 16 of them throughout this 120-foot boat. And at the top of the motor, there's a little hole to put oil in it. Well, the one that was jammed up against the ceiling, you couldn't ever get to the top of that motor, so no one ever put oil in it. So all this stuff seems to happen at 3 o'clock in the morning when the weather's bad. And, somebody comes and gets me up out of the bunk and says, there's a fire in the engine room. So I run down there, and the motor had started to heat up so much that it burst into flame, and it caught the coils on fire. So when copper burns, it burns like green. And one of the scroll cages, there's one on each side, the axis went through the motor. One of them was plastic and one of them was aluminum. The plastic one melted immediately. the aluminum was still going. I mean, in a weird place, I was just so proud of that motor, right? It's on fire and it's still trying to do its job for us. But that scroll cage is going and that green flame is coming off the windings of the motor and it's twisting to make this really cool looking tornado. I had to put the fire out because I wanted to live, but it really looked cool for a second. You're a firefighter, you know what I'm talking about.
Oh, yeah.
Yeah.
I stop every once in a while. Oh, that's
Yeah.
cool.
So, and that's why on my boat, my wife and I live on a 38-foot trawler down by Fisherman's Terminal. I have a CO2 fire extinguisher in the cockpit. And I like to have that one handy because the ones that you buy at Fisher's and stuff, that's the bicarbonate, you know, you use those. It takes you a couple years to clean all that up. But a CO2 one, they don't make them small, they're kind of big, but they're really worth it. They're really worth it. So I put that fire out and it just, what it did, besides scaring the shit out of me and make me, you know, kind of think about what am I doing for work with my life? You know, because 30 miles offshore is, it's a long way to, you know, we're not going to swim that, you know. As a matter of fact, you know, I don't do a lot of public speaking, but the ones that I've seen that I think were pretty cool, the folks had either a quiz involved or prizes. How do you feel about that?
I like prizes.
Okay, I got a prize here. But the question is, does anyone know, and probably there's a lot of people here who do, exactly how the distance is from West Point to Skiff Point?
Not me.
Anybody?
I don't even know where Skip Point is.
Directly across from West Point. It's one of the narrowest parts of Puget Sound.
Oh,
Right there. It's
3.5 miles.
it's 2.5.
Okay.
It's 2.5 miles, but here, you gave, yes, you get a sticker. So my point is, whether you're 30 miles offshore or you're 1.25 miles off the beach, when that happens, you know, that's a long way to swim and the water's really cold. So a way to decrease the percentage chance of that happening in your boat is to have the right tools, study the regulations and do it right. And you can't put too many fuses or too many, you know, breakers on it. I mean, you're not going to get in trouble for doing 2 of them, you know, or putting one on the negative. Somebody may make fun of you, but it's going to be an extra precaution to stay out of trouble. So there's that one. So one of the couple of things I want to talk about are the top 10 owner mistakes in boat wiring I see. The top 10 ABYC, you're familiar with the American Boating and Yachting Council? Y'all heard about that, right?
Yeah.
Top 10 requirements every small boat owner should actually care about. What's in the marine electrician's tool bag? I brought a small sample of stuff that I use every day. Best practices for running, securing, terminating, and labeling wires. And labeling is something that I don't see it done a lot. And I think if there was one thing that could save people money is when you have to get to a point where you have a professional electrician come, if you have that stuff labeled, then like I'm at $125 an hour right now. S3's at $150 an hour. So to pay me to spend 4 hours noodling around back under your helm about where goes what and what, if it's all labeled, I don't have to do that. I can just diagnose it and fix it. And I don't have to kind of go through the forest of what's going on in there. I know what's going on there. I've seen it. I've been in some of those boats, you know, so the labeling is pretty important. It's hard to do. It's, you know, you get it running and you get excited. Okay, I got the gear running. Let's go out and go sailing. But if you just took another 10 or 15 minutes and cleaned it up a little tighter, it would save you money in the long run. And finally, I'm gonna,
175 now.
Yeah, right.
That's great. Like, if I would have labeled it, but I wasn't the one doing it.
we'll have a question session after, you know. I'll be happy to address that. So my goal is to not make you guys electricians. My goal is to help you avoid expensive, smoky lessons, and then when to stop, step back, and just call somebody, you know, or do some more research. You know, I mean, there's a lot of resources out there for you, but just to kind of just go a little slower and be careful. So the top 10 owner mistakes I see are using household wire on boats. I see wire nuts, and wire nuts are just absolutely crazy. If something does go wrong on your boat and the insurance company is gonna come down, look at the boat. If they see one wire nut, they're gonna turn around and they're gonna go home, and you're not gonna get a dime. Nothing. If they see one wire nut on the boat, you're done. So it's not a shortcut. It's really a huge mistake, and I see it too often. So the difference between the Romex that you get at Home Depot is it's just solid copper. And then the nice wire that we get at Fisheries is stranded copper that's all been tinned. So the whole piece of copper has a plating of tin on it, which really knocks the ability for the wire to degrade and oxidize because it's sealed from the air. So that's why the wire is so expensive. So, the mistake number 9 I see is undersized wire. So there's a pretty particular marine DC wire ampacity chart, and this is just physics. You know, the amount of amps, which you can think about as the analogy would be plumbing, the amount of water flowing through a pipe. If you're trying to get too much water to flow through that pipe, the pipe's going to break. So they want you to use the right size wire for the amount of power that's needed. You were talking about getting a windlass on your next boat. That's going to be a pretty big wire. My brother, who calls me, and he just works me for like, how do I do this on the boat? You know, what do I do this? And, you know, I might get a beer once in a while, but he's not writing checks, right?
Yeah.
So he wants to put a windlass up on his Baltic 39, fancy finish offshore race boat. I crewed for him a little while. He raced it. I quit because there's, you know, every halyard on the boat is black. And I'm like, dude, how do you expect me to know what's going on here? Because all the lines are the same color. And he's like, no, that's cool, man. And I'm like, well, all right, well, so he wants to put a windlass up on his a powered windlass up there. And I'm like, great, this is how you do it. This is what the draw of the windlass is. I want you to use like 2-aught wire, run it from the house bank all the way up through the boat, you know, have the proper circuit protection here, do this. I made him a sketch. I sketched it for him. That's what a good brother is.
You love your brother.
I love my brother. So I don't hear anything from him for a while, which, you know, we go through gaps. He's family. So he calls me up. He's got a problem with his windlass. I'm like, you got a problem with your windlass? Oh, that's sad news. What's going on with your windlass? He's like, it won't work. It won't work. Oh man, that's too bad. He's come look at it. I'm like, no, I'm not gonna come look at it. You bring it to me. So I made him come and bring the boat. I was living out on Odock and Shilshal. So this is what he did. He didn't want to buy the right size wire. So he bought a battery. He put it under the windlass. And then he put a battery charger next to the battery. And then he plugged the battery charger in to an inverted outlet. So what we now have is the alternator is running, making DC power. It's charging the house bank, which is connected to the inverter, which is making 110. So every time we go from 12 volts to 110, we lose power and we create heat. So now he's got his outlets hotted up from the inverter, from the alternator that's charging the house bank. And then he's got a charger up in the bow, charging this battery, running the windlass, instead of doing it the right way. So he burnt the windlass up. So it was running on low voltage,
Oh my.
just didn't take care of it. So it cost him 3 times what it would have cost him if he had done it right. And I don't work on his boat anymore. So the right size wire is really critical, really critical. And you know, some of the boats that I hear you guys have are like 30-ish, 30 feet, 24. So, you know, that's still a decent run, and you've got to calculate out to the device and back to the batteries. So both ways, add a little bit more for it. And that's how far you're asking the electrons to run, and what the table's got footage.
So you gotta, I didn't realize that it's not sufficient to just calculate from the battery or whatever to the device. You gotta double that.
It's a round trip. It's a round trip. So, and that's a real common thing.
But doesn't the windlass eat up a bunch of those electrons when it's doing its work?
Yeah. Kind of like pipe. Exactly.
Usually the tables have like 2 drops, 3% and 10% or something like that.
Exactly,
So,
they do.
Is there anything that runs well at 10% increase?
You know, non-critical loads are considered lighting. A critical load, I would want to be my VHF radio to call for help to see if someone can come, take the time to come get me because my boat's not running. So sensitive electronics, your chart plotter. Do you guys have autopilots on your boat? So
Solar pilot.
tiller pilot, I mean, I would call that a sensitive load. So the 3% drop, that table is different than the 10% drop. So you make a great point. Thank you for that. I mean, my boat, I kick it up another size, you know, because what we're doing is like, I'm gonna go from the battery up to where my wife and I live on a, I've complained about them a lot in my life, and here I am, I live on a Bayliner. But like coming from the house bank over to where the helm is, where the electronics are gonna run, you know, I add up what the load is on the electronics, I'll double it or triple it for the trunk line that's going up to a fuse block, and then run off the fuse block to the chart plotter, to the VHF, you know, to the philometer, all that stuff. So now that that wire is bigger, I can add more stuff and still be within the limits of physics. Whereas if I just added up the minimum it needed and used that number cable, I can't add anything else without making that cable bigger, running it back through the boat. So that's
Double it.
big. Well, you know,
Next size up.
it's a little bit more money,
Yeah.
but you know, how long are you gonna keep the boat?
Yeah.
Right? I mean, a lot of my clients are going, should I get the lithium ion? I'm like, you know, it's a big bite. It's a big
Yeah.
bite. I mean, we can do the same thing with the boat using an AGM. And it's not cutting edge technology, but you know, my trade rags are talking about sodium ion batteries coming down the road. A little bit bigger battery, but doesn't destroy the environment as much as needing rare earth minerals, and it isn't as expensive. So the Chinese electric car company that's in Tesla up, I think it's called BYD now, their latest cars have a combination of lithium ion and sodium ion batteries. So, you know, I don't speak for a living. I work on boats for a living, but to get ready for this, I kind of, you know, went through the YouTube-y thing about what are the marine electricians throwing out there. I was kind of appalled in a little bit of a way to see what how much gear they're trying to get you to consume. Is it really necessary? I mean, what do you want to do? You want to get out on your boat, you want to get out and have some fun, you want to do the race, you want to go cruising. You don't need to spend that much money on super high-tech gear. I mean, if you want to, and it's sort of a joyous thing just to be in the technology of it, then go for it. But I found some of the stuff I saw on the internet about, you know, their suggestions of how to build systems. I found them over-designed, overbuilt in a lot of gear, but.
Like batteries and chargers and stuff like that you're talking about.
Well, yeah, like specifically, you know, going back to the lithium ion thing, like putting a class T fuse in between every battery when it's already got a battery management system inside the battery, BMS they talk about, but all that is a fuse, you know, or a relay. So they're trying to reinvent technology that we've been using for 100 years and repackaging it and sell it to us again. You know, so buyer beware. I mean, definitely do your research and see what's out there. So undersized wire, we covered that. Chafe protection. So I brought some stuff around, Vince Catch. That's one of my favorites going through a bulkhead. They sell them at fisheries. If you drill the hole the right size, it just pops in there, and then you can run cables through that. And you know,
And this is available in different sizes or?
yeah.
Oh, that's.
So
Or you just take the rubber pipe I did and just slice it, shove it in there.
that's another good way too.
Yeah.
That's another good way too. Like I said, there's many paths to success.
Is that also available in different thicknesses, for different bulkhead
It
thicknesses?
is.
What's it called, a grommet or?
Yeah, it's prettier too.
It's a kind of grommet. That's a specific company, and you can take a look at it, and they've got you know, every size you can imagine, and they work really well. I mean, the trick is to drill the hole the right size so it fits in there tight, right?
Right,
And then I mean, it looks like a professional installation.
yeah.
I mean, a lot of the things that we want to do on our boats, it makes me sad sometimes, but I'm going to sell the boat one day, and I'm going to get more money when I sell the boat if that's the chafe protection instead of it's
Does
just
anybody
going.
sell these locally?
I bought that at fisheries, I think.
Pardon me?
I think I bought that at Fisheries. Yeah.
There's a marine electrical place in, kind of the industrial area of Magnolia. I think it's called
Elmore.
Elmore, yeah. They've got all kinds of real nice like boxes to put connections in and terminal strips.
Where's that?
Elmore Electric on, it's not far from you off of Commodore.
Oh, okay. Oh, right. Yeah. I've driven by there. Those guys do a lot of commercial work.
Yeah,
Yeah.
but they sell, all kinds of pieces and parts, if you need it.
Oh, thanks for that, Ed. I'm gonna check that out. My shop is just down the block from there. That's kind of a neat part of the city right there. There's a lot of industries down there. Chafe guard. Obviously, when we're running wire, a kind of a rounded loop is better than having a sharp kink on it. And the ways that we can support that wiring are, this is a piece of stainless with rubber around it. It's called a cushion clamp. So that's what the ABYC wants to see. Anywhere that the wire is going over an engine room or engine space where it gets hot, they want something more than just
No, they don't. Oh.
like here's a little cable tie clamp and a cable tie. If it's running over somewhere where it's hot and that has an opportunity to melt, then the wire is going to fall in the engine, and it goes poorly quickly after that.
So you're saying ABY, they don't like wire ties?
Not over an engine.
Yeah.
Okay.
So in an engine room space is fine, but if the wire run is going over a hot exhaust pipe, exactly, the plastic isn't going to do it. This is I usually keep it in the refrigerator, but this is called weld mount, and it's a specific epoxy that has
You can put a tire ribs.
little nozzles that go on it, and if you keep it cold, it lasts longer. And I'll pass this around.
Bob, before you do that, do you mind showing it to the camera so people who are online can also see what you're?
I don't. Where's the camera?
It's this little green light on the computer there.
Oh,
You just
okay.
Hold it up in front of the green light.
So that's weld mount, also at Fisheries. And every time you use it, you got to put another schnozzle in it, and it just takes, it's a 2-part epoxy, and it mixes it in the nozzle. And then these saddles have kind of a texture on the back, and you glue that up and slap it up a couple minutes, and it's, you're not gonna be hanging from it.
So it cures that quick.
Yeah. So, on Vince's boat, he's got a wireway in the back on the way to his new outboard, and he's epoxied up some wood, and he's got.
That's not wood.
Excuse me, it's carbon
Yeah.
fiber that's been hollowed out. It's special carbon fiber that's made by, black widow spiders in Ireland or something. I don't know what it is. But anyway, like, you can use that epoxy and go right up against the fiberglass, and it's held up really well. So the unsupported wiring, really bad, every 18 inches at least. And it's like the fuse thing. You're not gonna get in trouble for putting more circuit protection than the book says you should. Yeah,
So, when you got, let's say you're adding a wire to, there's a bundle that's going along, and you're gonna add a wire. Is it best practice to just add another wire tie, or should you cut the old wire tie and bundle them all together, or what do you do?
I add another wire tie because they're already up there pretty cool. I mean,
Yeah.
ideally, I'm a little ADD. They're all in line, if I'm installing gear, and
What do you mean,
they're
the
all
little
parallel.
doohickey part is all?
No, all the wires
Oh.
wires are like little.
It's not bundled, it's just like a strip.
Little soldiers climbing along, ideally, right?
Okay.
All right, there's gold, silver, and bronze level. So the gold is like, they're all like that. And if there's wire ties around it and they're going through like one of these, you're gonna have to cut it.
Yeah.
But there can be bundling them. I go around it and I cut all the old ones off. So
Uh-huh.
there's just the ones that I did. And I meant to bring that, but you can get them at Platt, but it's a pair of really small side cutters. And they cut the wire tie completely flush with the end of this.
Mm.
So I have bled profusely in my career from these being cut at a 45-degree angle, and they're sharp. So if you cut it with, you know, the cable cutters, if you cut it with your wire strippers, it's not good. It's still sharp. So these little pliers, and I'm sorry I didn't throw them in my bag. Cloud Electric, they're like $25. They're expensive, but I have considered with, you know, colleagues buying like a crate of them and just ship them into China where they build these boats and giving them away so that boats won't come over. You put your hand, you're putting your hand up in something and you're coming out and you're bleeding. You know, that is not okay. It's not
Yeah.
okay with. All right, drip loops. For anything, you know, small boats, rains come down the companionway, anywhere where it's gonna come on contact with a wire. If you run the wire straight to the terminal, water can run all the way along the wire and start eating away at that terminal. If you come down, do like a 2-inch curve and come up, you can put one of those cable tie mounts down there. But if we put a dip in it before it comes up and attaches to the breaker, then that water will drip down there instead of going at the equipment. Something real easy you can do, and it saves a lot of equipment. Because, you know, you can't get rid of the water, especially like this time of year when it's raining a lot. It's just, you know, it's what we do is a wet endeavor. So even if the electronics aren't getting hosed down, the environment, like I go on a boat and someone will have a dehumidifier there. Isn't that adorable? I mean, it's a nice idea to try and pull the moisture out of the air on the boat, but it seems like putting your finger in a dike or something. You know? We're at sea level. The humidity is 98%. It's just, that's the environment that we exist in. That's the environment we ask these electronics and electrical panels to exist in. And anything we do to keep the moisture out is a good idea. This is something that the guys at the American Boating and Yachting Council are adamant about. And I have seen it maybe 5% of the time of every boat I've been on. I've been on a lot of boats, which is separating the AC and the DC wires in separate conduits. I mean, if you can do it on the gear that you're installing, that's a great idea. If I ever built a boat, I'd have, you know, 3 2-inch pieces of conduit going down the whole length of the boat. One for AC, one for DC, and one for my VH antenna cables. Because what happens is that VHF antenna cable gets wrapped up with the AC and the DC, and it just destroys the signal ability of that cable to get your call out the antenna. Because the impedance of that AC wire, if you've got an inverter on while you're underway, it just wrecks hell with the signal capability transferring in the electrical cable. So ideally, they would want that in a separate bundle. So if you didn't have the conduits, you could do 3 separate cable ties next to each other, do the AC in one, the DC in one, and, you know, keep your VHF stuff as far away from the AC as you can.
That's what I was gonna ask. Is there an ideal distance, like at least 12 inches or as
No,
far away as you can?
I just don't want it wrapped up in a tube. If you can beat that, you've done a lot right there. Mistake number 4 is no overcurrent protection. You know, I pick up the newspaper and it says, oh, like the Seattle Marina burned down again, right? How many times has that happened in the last 20 years? A lot, right? And people go, oh, I wonder how that happened. I don't wonder how it happened. I know exactly how it happened. It was grandma's lamp. You know, it was an old piece of gear that we didn't want to rewire. And you plug it in and you leave it in and it just starts building up heat, building up heat, building up heat, and then it lights off and it goes. And a broker I work with was on his way up to Anacortes, and apparently they had a fire up there last weekend. And a client of his had just bought, I think it was a very expensive Nordhaven boat. The boat next to it burst into flame and burned his boat down too. So that's the worst, you know. I mean, if you burn your own boat down, you kind of deserve that. But if your neighbor burns your boat down, that's a kind of a different feeling for me. I don't know.
It's kind of like the mountaineers. It's like you buy your skiing partner the best, biggest shovel and avalanche transceiver, all the good stuff. You buy your neighbor the best fire protection stuff.
Absolutely. I got that CO2 extinguisher in my cockpit. I'm ready to go because I see the boats that are around me going, oh my goodness. All right, so overcurrent.
Speaking of burning boats, what do you think of a smartphone?
You know, I try not to talk trash because it's a small lake and a small town, but honestly, the ones that I've taken apart and installed, I was not impressed about the robustness of its design. I like the idea of it having a double locking technique where it hangs onto it, but like 99% of the time, the other end of the cable has got a regular plug into the power post. So, and the pieces of plastic inside it, when I was trying to put it together, like were breaking in my hand. You know, I just felt like it was good design, but it's got to be challenging to try and get something made in China at a reasonable, you know, rate that you can get it back here and sell enough of them to make it go. So what's going to happen? They're going to decrease the thickness of those little pieces of plastic that are inside of it until you get some guy like me talking crap about it.
You have some examples where smart plug is failed?
Just the one I said, you know, I'm trying to assemble them on wire. I hope you don't work for Smartplug, but you know, it didn't go together very well. I thought the strain relief inside the plug, this trying to keep the wire from pulling out, was not of robust design. So I'm mixed in it. I like the idea of having a locking plug, but if you have your 30 amp cable with the screw on it at your boat, that's going to work if you actually screw that thing in, you know? So it's possible to have that connection be safe, but it is a difficult connection because it's in, it's out. Every time we take the boat out, it gets a lot of use. So again, I don't mean to speak disparagingly about it, but I wasn't impressed with how it was built, but I was impressed with the idea. So drip loops, mixing AC, DC, no good. Overcurrent protection. So the ANL fuse and the Class T fuse, is that stuff that you guys understand or work with?
No.
Like one versus the other? The ANL fuse is like, that's like 30 to 300 amps and it's slow blow. That would be something that I would put on a charger or an inverter where, you know, there's a higher amperage for a little bit and then it calms down.
Did you say ANL?
Yeah.
Is that the type where you push the button and then a little lever comes out?
No, that's a circuit breaker, and Blue Seas makes a great one. And I like that one because you can see if it's tripped from across the engine room because that little yellow tab comes out. That's a circuit breaker. These ANL fuses and Class T fuses would only be on your bigger battery banks or bigger inverters. So like that fuse that was in between your battery, that may have been an ANL fuse that we replaced. What was that, an 80 amp or something like that?
Yeah, $50.
They're not cheap.
$50 fuse.
Don't do it again, miss.
No, okay.
But at that point, when do you pick between a circuit breaker, which you can just reset, and a fuse, which you have to go and buy another one?
That's a great question. My personal preference would be to have a circuit breaker that you can reset. There isn't a standard that I'm aware of where you can get in trouble using a circuit breaker instead of a fuse. Typically, a breaker is going to be more expensive, so you're having more of a financial outlay immediately, but it's a more robust design in terms that you can reset it. But on that point, fuses blow and circuit breakers trip for a reason. Why? You know, I mean, if you have to keep resetting a breaker, I get silly photographs all the time of people sending me stuff like bad electrical work. I wasn't going to bring any tonight because it's ridiculous. But someone had in a household panel taken bare copper wire and tied a knot in it to hold the lever on an AC breaker that had tripped to hold it on, and then tied it on the end of the thing. So that kind of stuff is really going to get your house burned down or something like that.
Breakers. Another thing that can happen with breakers is the breaker can weld itself in place. And I've seen that happen. So don't
Closed or open?
Closed.
Huh?
Yeah.
It's not supposed to do
It's
that.
not supposed to do that, but it can if it's.
Was that a magnetic breaker or a thermal breaker, or do you remember what kind it was? Was it a house breaker?
No, a commercial electrical
Huh.
breaker. Yeah.
Yeah.
So it was heavy load over a long time, like right up to the.
That's not
like
doing
17
that's not
amps.
doing what its name implies. It's a breaker,
Exactly.
right? It's supposed to break before it kills you.
So it can happen, but a fuse doesn't have that failure mode.
Right. That's a
But
good
like
point.
you were saying earlier, there's no rules. You can have a breaker and a fuse.
Yeah.
So if you put the breaker,
You know,
if you rate them right, you could potentially have the breaker tend to trip before you would burn out the fuse, but the fuse still be insurance.
Hmm.
Would be
yeah,
viable, right? There's no-
absolutely.
You can't not do
Absolutely.
that.
I would never tell anybody that's a bad idea. It's just, you know, we're working with a system where they're trying to put as little amount of money into the system and make it safe. Putting additional circuit protection is more money. So we don't see the boats show up from the manufacturer like that, but it's certainly a good idea. The first VHF radio putting in, you know, as a high school guy, they had a fuse on the negative and the positive side of all the radios. They don't do that anymore because you had to buy 2 fuses, not 1. But it was just an extra layer of protection that used to be an industry standard and isn't anymore.
So a kind of a theme or a rule I've been reading about recently is the fuse should protect the wire,
Very good.
not the device.
Mhm.
So that when you step down, like you have wire going to a bus bar, you may a thicker wire going to a bus bar, you'd have a higher rated fuse on that. But then where you have lower diameter, lower ampacity wires coming from the bus bar, they should have a smaller fuse on them.
Exactly.
And we want to talk about that because that seems like a pretty important.
Yeah, absolutely. No, that's a good point, that the circuit protection we're using, and again, I'm going to keep saying the ABYC thing because they can be frustrating, but they also are saving people's lives by trying to get the work done as professionally as possibly and with the least amount of fires out there. Because I already talked to you about it. I'm scared of the fire. You know, I've seen it and I don't like it. So within 7 inches of the battery is where that circuit protection is supposed to be. So the main feed that goes to your DC panel, that fuse should be within 7 inches of the battery, and it should be rated for the wire that goes up to the panel. And at that point, the panel are the branch circuits, and those are going to be, you know, the 10, the 15, the 20 amp, but you're going to have a bigger cable going up to that. So sizing the fuse or the breaker for the load isn't necessarily correct. You're making a great point. It's for the wire, because it's the wire that's going to warm up. And you know, the worst case scenario is it warms up so much, it's sort of like global warming, right? As the polar ice caps melt, there's less, you know, this color reflecting the sun back to space, and it's dark and it's water. So the water is absorbing the heat. It's exponentially advancing instead of arithmetically. When that wire heats up, it loses its ability to pass electrons. So instead of a 2-aught cable, now it's a 1-aught cable. And as it gets warmer, it's just going down the list of being less of a cable, and the heat builds up even quicker. So that's why the protection is for the wire and not the load. So they're very important calculations, and that's stuff that, you know, you can't spend too much time double checking that when you're building something on your own boat.
But so
Let's say that if you have that 100 amp windlass you were talking about, let's say 100 amp, whatever. So you want a breaker you're gonna have an amount of wire that can take that 100 amp load. And you don't necessarily need a 100 amp breaker. You could, but what you really want is a breaker that's gonna stop that load on that wire from getting too much, not the load at the device.
Right. But depending on what size the wire is how we're gonna size the
So let's say you
breaker.
use a 2-aught and it can take 150 amps over its distance. Even though your load only draws 100,
Depending on the distance.
depending on the distance,
We're gonna size it for the wire.
you're gonna size it for the wire. So you might have a 150 amp breaker or fuse on that, even though your load's only gonna draw 100, but your wire can only take 150, so you go that way.
You know, you're bringing up a good point, and I wanna take a break and show you this. And this is something I don't see a lot of folks doing when they're putting gear on the boat. And I do it on every motor or every windlass that I install, and pretend this is the windlass. So it's on. Right when I install it, I take this is a Fluke 347 FC, and it has a clamp on the end of it. the clamp, put it around the wire. I've got this set to AC, because this is an AC load for the windlass we'd be using DC. And I clamp it around it, and it tells me, right now, this light bulb is pulling 0.2 amps. So I write that on the windlass, how many amps it's pulling when it's new. Because when it's new, it's gonna pull what they say on the package. As it sits in our salty environment for 5 years, it's gonna pull more. So that's why I want that breaker to be sized for the wire. Because the motor is gonna pull more amps the older it gets.
Even though it's a 100 amp load now, 10 years from now, it might be a 140 amp load.
And if I
Wire can
write,
only take 120, you're gonna blow your fuse.
and if I write on the motor what it's pulling when it's new, I write the date and a Sharpie and what it's pulling. When we come back to the boat in 5 years and the windlass is running slower, or the windlass isn't running light, or if you're my ding dong brother, it's not running at all. You put that clamp back on it and you see, oh wow, this isn't pulling 40% more power now than it was new. So we gotta pull it and rebuild the gears or get it lubricated or something like that.
Would you mind you pulling that up and showing how you put the clamp around the wire or on the wire?
Just snaps around.
It's just gotta go around one of them.
So it just goes around one.
It goes around one,
Positive
and
negative.
you can buy these guys that do AC. They're a lot more expensive that do AC and DC. But
So you're putting it around the wire, not clamping it on the wire.
exactly, it's got to go in here, and it's reading the impedance.
Gotcha.
So it can kind of get a sense of how much power is flowing through the wire. It's not reading the voltage, it's reading the amperage.
Right.
So this is a super valuable tool, and one that really helps in diagnostics for that reason. But I want to make sure that we address your question about the big cable going to the windlass. We're going to size that breaker for, or the fuse for that device,
Protect the wire.
for the wire, and the device is going to be within that range. But when it gets old invariably and starts pulling more power, our safety is going to be that breaker or fuse, A&L fuse. I wouldn't go with a maybe choose the class T on that, because that's can handle more power. That can go up to 600 amps.
Isn't it fair to say that you would, go back to your 7 inches from the battery comment, you would put a fuse, let's take the windlass example, you're running a wire to the windlass, you would put a fuse near the battery to protect the wire to the windlass. But near the windlass, you might put a fuse to protect the windlass,
I'll put a breaker up there.
put a breaker up there.
Like
Yeah,
on
so
a-
this, it's not like, it's not one or the other, maybe both is
Do both.
appropriate.
That's what I'm trying to encourage you.
Yeah.
Like, you're not gonna get in trouble from me for putting extra circuit protection
Yeah.
in it, because it's gonna save.
And
it's
they're
gonna
very
save-
different. And you may have a big ass wire that could take 200 amps, just pick a number out of thin air, but a device that can only take 100.
Mhm.
So the 200 amp fuse is not going to protect the device at all, because clearly it could now allow far more current than is protecting the device.
Unless the device
So now you have another.
goes up that high.
Yeah.
But we'll
yeah.
have something in
In
between,
between.
where the wires delivered that power back at the battery is the fuse that's protecting that wire. And then let's fuse it again up to the device.
Yeah.
Rated at the device.
Rating for the device.
Right.
And in a sense, that's what your comment about the circuit breaker board
Mm-hmm.
is doing, isn't it? You've now got, a big fuse on the wire to the board, and then
A main
board
breaker on the
full of
board.
Little
Uh-huh.
breakers that are protecting the devices that are hooked into the board.
Do y'all have inverters on these boats?
Cigarette plug lighter.
Not typically.
Cigarette lighter.
Most of them.
I mean, these guys have them.
Yeah.
So when I wire an inverter, I'll take up space on the panel to go from the AC panel that feeds the charger side of the inverter. So there'll be a breaker for inverter in and another breaker for inverter out, and then that will feed the outlets on the boat. So that's adhering to that philosophy of adding an extra layer of protection. And I can also isolate the inverter when I'm working on it and not worry about getting zapped. So you get more control.
I want to point out that this wonderful fluke tool is $700.
Yeah.
You get the DC.
They make them less expensive than that.
What's that now?
I think the DC only is a lot less expensive.
Oh, is that right?
Yeah.
Okay.
Might be 250 bucks.
No reasonable quality now.
And a lot less useful, I find, because,
Yeah, well, a lot of us don't have AC on our boats.
I understand.
So,
Right, backing up just a little bit.
Sure.
You said that as the motor on the windlass, as an example, gets older, it takes more electricity. So at a certain point, it becomes a problem. Is there a way, do you rebuild the motor, or you have to replace the windlass, or what do you do?
On the 80-foot boat I run, I have 2 spares of gearboxes. And every year I drain all the gear oil out of it. And if I'm not bright enough to do that in the summer, I'll put a heater up on that gearbox for a couple of days before I drain the fluid out of it. So whatever you can do with lubricating it. And I mean, it depends. I mean, I'm kind of getting the idea that your boats have kind of the smaller windlass that's flat on the deck with the capstan that goes around.
Yeah, mine is, but it's my halyard windlass or winch that has me concerned.
Okay. Yeah, no, I bust it apart and change out the pawls and springs and lube it up. You know, I would tell you every year, you know, depending on how much you're using the boat, and if you're taking it all the way up to Alaska and back, that's
But it's not the motor itself, it's the friction in the drive unit that's the problem.
both. You know, I mean, the motor's got brushes, right?
Yeah.
So, I mean, anything that's spinning around is gonna get slowly degraded over time just from the environment. So the best thing you can do is keep it covered up when you're not using it, try and keep the rain off of it. And this is like on your mast, pulling halyards. It's a mechanical or electric.
No, it's electric.
I like that.
Bulkhead mounted, it's inside.
Cool.
Yeah.
All right.
Okay, thank you.
All right, so back to the 7 inches from the battery. They let you go a little farther than that if you loom that wire up. So you can go 40 inches away from the battery if you put the wire in a loom or a conduit. Myself, again, I prefer them pretty close to the battery because then I'm not hunting around the boat for it and spending a lot of time on the clock wondering, you know, is it the blown fuse? Because I'm going to start the battery and then I'm going to work toward the device that you've asked me to fix, seeing if there's a break in the wire.
And you're talking about that split loom stuff, that plastic, black plastic?
So, is that the origin of the 7 inches? Because I'm intrigued, because obviously wherever the wire is, it protects the wire the same. The current hasn't diminished across the length of the wire.
No, but there's more of the wire that can suffer from the heat.
Especially at the crimp, if you've got a lot of motion at the crimp, where your lug goes onto the battery, I think is their issue with supporting it maybe near the battery.
I prefer not to see any motion near the crimp.
Yeah,
That's why
but I
we're
mean, that's
securing
what
all
they're
that
doing.
stuff.
Trying to protect more of the wire.
Okay.
All right.
So we wouldn't want to put the circuit protection in the middle of the wire.
Okay.
I want it as close to the battery as possible to protect as much of the wire, like the gentleman said.
Okay. Okay.
And it's easier for me to find.
Yeah.
So,
Yeah.
I mean, hunting around the boat looking for where the fuses are it's a waste of time, you know?
For our size batteries, I think they have the fuse that attaches directly to the battery, and then you put your lug onto it, et cetera. So it's sort of
The
between
MRB.
that battery.
Aren't those great?
Yeah, so it goes on the terminal. Thank you.
I love those, as long as you don't stack 6 of them on there, please. Right, do a biggie, and then come up to a separate fuse panel.
Yeah.
You know, and just do ATO fuses in those and break that off to your different loads. That's a perfect way to do it, because it's right there.
These are MRBF
Yeah,
users.
I'll tell you about
I've been reading about this a lot recently.
it's a wonderful invention.
Yeah.
I like them a lot, and
It's
they're pretty rock solid.
It's a little.
There
thing
are no
that you
stupid
attach
questions,
right
Miss
on the
Shirley
battery
May.
line.
What?
Little fuse. and
That's a
then-
fuse, I see.
No. So I have old boat that was built in 90s. It's called. The motor, thankfully, it's newer. It's 7, 8 years old. My question is, I'm sorry, it's a really stupid question. I'm now discovering the things that I never worried about. So now my question is, wiring and old or new motor, and that part I understand is some needs to be coordinated or synchronized, depending on the energy needs. So I have a new motor.
Outboard?
When you put the new motor onboard motor, it's younger. Do they technician replace all the wires for us? or it's completely separate, should I be checking that? What do you think? Sorry for the stupid questions.
No, that's a very intelligent question, and I have to be,
So
I
I
have to,
should be worried,
no, I don't want you to be worried, but I want you to be vigilant.
vigilant.
So the places to check are wherever the wires are attached to the engine, so that's
Right.
gonna be the starting circuit and the sensors.
Great.
You know, give it a little wiggle, you know, make sure they're not moving. And I have to be honest with you, every day is a school day for me. And I learn stuff every day. There aren't any stupid questions. And if we come back around and we cover the stuff again, that goes back to securing the wires and making sure they're bright.
Right.
So once that technician pulled that off, again, with the gold, silver, and bronze standard of work, if they had a wire wheel on a drill,
Uh-huh.
and they took that ring terminal and they
Mhm.
brightened that up real nice and then put it on, that's the gold.
Right, but maybe because they came to replace the motor, they necessarily didn't think about wiring. right?
The rest of the wire, so in a regular repower,
Should I
you wouldn't
check
you wouldn't
part?
redo all the wire.
If you took a Yanmar out and put a Yanmar in and I've got the same wiring harness, that would be cool, but I would brighten up all those ring connectors before I put them on the engine, because you got that opportunity, it's right there. You put them on the engine and they're 15 years old and they've got, you know, that patina on it already. Anywhere that is, that's gonna decrease the ability for the electrons to flow back and forth.
Mhm. Thank you very much.
You're welcome. It's a good question.
This is all like, you're talking about copper wire right now, right?
Tinned,
Tinned.
stranded copper wire, exactly.
Solved like half my problems.
Why, what do you got?
Green copper wire.
Green copper wire.
Yeah, I need to clean my copper wire before I decide to solve any other problems, and it might be the wire size too, so.
And remove those wire nuts.
Well, I don't know. I'm gonna like,
Oh, you're more,
well,
you're.
the wires that were like they came with the solar panel that like we had to kind of like strip and connect to copper wires of our own to connect to the terminal and then
Uh-huh.
for the solar panel and then to the battery.
Well, hopefully there's a solar controller in there somewhere.
Yes, that's what I mean. I don't know what all these terms are. I'm sorry. My mom
Oh,
was
she
an
missed.
electrical engineer, not me. But there's like a solar panel controller attached to the wall and then it attaches to the battery.
Great.
And I know that the wire leading from the solar panel, like the initial points that they give you, that is a very thick copper wire compared
It
to a
is.
very thin copper wire that it's like spliced to.
Ah, yeah.
But it doesn't look like there's much space in the solar panel controller for a much thicker wire. It could just be like wrong. I have no idea.
well, you're not gonna get in trouble using a bigger wire than you need. You're gonna get in a lot of trouble using the smaller wire.
Yeah, and
So-
I have no idea if it's too small or what.
And it's
Right,
pretty much just the math. I mean, what's the maximum that panel's gonna be able to put out on, you know, the July day where it's clear blue and the sun's right overhead?
Mhm.
You know, that, you know, plus 20%, whatever that amperage is, look at this chart, that's the wire.
Mhm.
And the solar controller should be designed where it will accept the OD or outside diameter of the wire that big.
Mhm.
And not to spur off on the whole solar controller thing, but choosing the right one of those is important too, because they're also rated for how many panels are in series or series parallel, like. Okay. Well, that ought to work then.
You
Had
can
both
also,
ports, we only use 2 in and 2 out.
you can also step down the wire. That's the thing that's become obvious to me, is that the wire diameter that you need is in part a function of the length of the wire. That you can have a smaller diameter wire for a shorter length. And
That's
step
not what's
up to.
Kind of like the opposite situation
Well,
here.
Then that's not the good necessarily.
Doesn't go very
um,
far, but I don't think it's.
Because it's
possible.
about how much voltage you'll lose. It's the percentage drop you talked about. So in a very short distance, you can have a smaller wire that will have a very low voltage drop connected to a bigger wire that's going to take you the long distance, which also has a smaller drop.
Almost amperage drop.
Yeah,
So
sorry. Yes.
it's easy to
It's amperage,
confuse
yeah.
them,
No, I'm
but
sorry,
you know, what we're rating the wire for is how many electrons are gonna flow
Yeah.
through it in amperage. So if it's smaller and we're trying to jam that through, that's where the, I'm gonna use the word friction inappropriately, but the heat builds up from that. But you're exactly right, running the larger cable up to that fuse panel and then coming off that with smaller wires right to the device, entirely perfect. But
So
yeah,
let's,
He's talking about
you guys,
the fuse panel though,
Yeah.
right?
Yeah, I'm actually talking about the situation you were describing. You may have a solar.
I don't think it's a good idea to make that run be large and then small before you get to the protection.
Well,
That's the battery.
and it's not good to do any of that butt connection and put it in
Yeah.
a chase or anything, because that's gonna take me hours to find at $125 an hour. You know,
let's, hey, you guys, let's, hey, you guys, we got an hour.
Thin wire, and then.
Hey, ladies and gentlemen, we got an hour already
Yeah.
in. This is very fascinating, but let's let Bob get through his presentation here. He's got another hour and a half or so.
3
Yeah,
hours. You guys need a pee break or anything? Cause I'm just digging in.
I think
Just digging in.
let's move through this.
Okay, so another thing that can happen is your gear starts working intermittently and you're like, what's going on with this thing? And you're looking at the gear. A good place to start is the ground. Inappropriate grounds are not all tied down to one main ground terminal. So they sell a bus bar that's about 10 inches long. It's got 3/8 studs on it. Every ground on the boat should go to that. Back in the day, we just used to use the engine on an inboard boat, like your boat. We would just tie stuff to the engine. We don't do that anymore. It's a specific block of tinned copper and put everything in a ring terminal to that. And that cleans up a lot of problems on boats because it's that flow of electrons when they get, throttled down a little bit from multiple connections. Anywhere there's a mechanical connection, there's going to be a drop. It's just like plumbing, I mean, we're gonna do the plumbing where there's the least amount of fittings as we can, because there's the least amount of spots where it can leak. Kind of the same thing with the electrical. We want the least amount of connections. So let's bring all those grounds down to one spot, and that'll clear up a lot of stuff that I find on boats. If it's AC, floating neutral, and we'll dig into that a lot, but that happens on stuff. I've run into boats, you put the meter on the panel and there's 70 volts. How weird is that? There's 110 coming into the boat, and then here it's 70, because that neutral is loose. So it's called a floating neutral. And there's physics in it that's kind of up here, but that's what happens. So overcurrent protection, poor grounds, crimping. A regular pair of pliers is not the right tool to crimp those terminals. I like these long handled ones. They, Blue Seas makes them. There's a bunch of different brands, but they have a curved spot and then a part that kind of pins into it. Those are good. These are better. The ratcheting and this die, you can spin it around for different size stuff. So the bigger wires that you're going to run from the battery, you want to pass those around. Watch your finger in there. The bigger batteries, the bigger wires running from the battery up to there that are going to be, number 2 wire, number 1 wire. You can't crimp those with these because it's just too much force is needed to close it. So that's a box crimper. It crimps them from outside on 4 sides and gets a really good, the material that the terminal is made out is soft and it crushes down on it. Got to give that terminal a good pull. If you can pull it off, that's not good. You got it. It's supposed to withstand, there's a different Coast Guard regulation for how much it's supposed to be able to withstand from just hanging with putting a weight on it. But if you can pull it, then his start is probably good.
Can I just ask a question? Do we have some of those in the club's toolbox, as it were? Because that might be
I think it's safe to say that we don't, from
Yeah.
my last.
that might be a useful,
The
they're
whole
quite expensive
It would not be a bad.
Yeah.
item.
So the question on this, those won't do the 1 or 0, right? The only 2 is the biggest size they'll do.
They make different dies that you can change out. So it would do a number 2, but like what I use to crimp a 2-aught terminal, which I'm using with batteries, those stand that far off the ground. They got big long handles on them and
Right. So I've used the hammer style.
So,
The hammer ones are really expensive. The
so
big
right.
version. Yeah.
fisheries who sell you the wire and the lugs also have a crimper.
Yeah,
For those big ass wires.
yeah,
So
and
you can do the,
I ran into a thing with commercial fishermen. I was helping them wire. And any place where we put a crimp, where we put anything together, he put a little bit of like a light duty grease in there. And his thing was, we're gonna crimp to the metal, but the grease will keep other things, you know, salt water or corrosion from starting. Have you seen that too?
I have not seen that, but I don't think it's a bad idea, especially if it's something like that's gonna be in the anchor locker, that's gonna get washed a lot. Either with, you know, I like to hose that chain off when it's coming on the boat, keep the salt water out of that anchor pocket, you know, so anything you can do. You know, there's a liquid electrical tape you could paint around the terminal after it's crushed. But grease is a good idea too.
Isn't there something called dielectric grease?
There is.
Put connections together and stuff?
That's probably what the
That's what
gentleman's
he's
using on
talking
his fish boat,
It's
yeah.
gotta be conductive.
No,
Not necessarily, because we're just trying to keep the air off of it.
It's.
I see you with your hand raised. I'm gonna get to you in a second. There's a product I like to use called fluid film. And like in my engine room, anything that's bronze, I hose it down. Because all what we're trying to do is keep the air off of it. So it's a kind of a sticky oil, like Croil that I get at Tacoma Screws, like $35 a can. It's worth every penny to me because it's a crawling oil that it's really sticky. So if that bronze sea strainer, you know, they get green after a while. If you keep the air off them, they stay kind of nice and bronze and they don't start to degrade. Because when that green hits it, then it's going to start working on the fasteners on the lid, and you're going to end up buying another one if you keep the boat long enough. And when you go to sell the boat, someone comes down in the engine room or looks at the compartment and that stuff is shiny. It's not green. So that's a good idea. Do you have a question, Sue?
Yeah, what do you think of those, like ring terminals, that you can put a wire, strip of wire back, put it in there and you heat it up and it has a bit of solder in there that we melt down and it's the vacuum or the shrink wrap goes over the top. It's kind of all in one step.
I have wire ring terminals that have shrink tube integral with them, but I would prefer to crimp it.
Some of these I've seen actually have a bit of solder and you put it in there and it's not, when you heat it up, it melts the solder and holds it.
Not on my boat.
yeah.
I mean, you can solder them after you crimp them and then shrink tube them if you got a lot of time and it's your boat and you want to do that. But something like that is like, you know, anything that's too good to be true or automatic, I think it is too good to be true.
Well,
Isn't there another issue with
very
solder?
small gauge wires, it can be quite helpful. You know what I mean? Cause it's clear, so you can actually watch it and it all goes.
Oh, you use this stuff.
On, on
Yeah,
small
small,
gauge
small,
wires,
that's-
yeah, we're not talking big.
We're talking be very small.
So like-
I've
like-
never seen
Like
it on that.
data cable, like Cat
Or-
6 stuff or something.
So I thought soldered connections were a no-no for 12-volt because if there's a bad connection, it'll heat up and it can melt the solder. And if you in any way rely on that solder for a mechanical connection, it's like a recipe for disaster.
That's why I would prefer to crimp it.
Yeah.
But
Yeah.
putting a little solder on
Doesn't
top
need-
of the crimp isn't
Okay.
gonna make it not be crimped. It's just
Okay.
gonna, you know, fill that void a little bit. So I don't typically do that on my own work on my own boat, but I don't think there's anything wrong with it. You know, a good solid crimp and then having it shrink
It's
tube
the
is
thing,
enough.
it's the key part. It's the first thing you said, that the good solid crimp.
Yeah.
Well,
Yeah,
if you have
5
tin-
volts,
if you have tinned wire, it's just gonna make the tinning go all through the joint. Are you taking advantage of the tinning?
Sure. Yeah, because when you cut the wire, you've exposed the copper. So if you tin it after you crimp it, then you've, again, going back to keeping the air off of it, right? Because that's what, you know, teak is my favorite wood in the world because it's got more silica in it than any other wood on the planet. So it starts to oxidize and actually covers itself with a layer of glass and then it doesn't oxidize anymore. Kind of same thing with stainless. I mean, it'll oxidize down to a point where it seals itself out from the air. And if it doesn't get any more air, it's not going to oxidize if it's, you know, 316, not the 309. I don't think there's anything wrong with running a little solder on that when you're done crimping it, but you know, you guys like those it's kind of a fancy automatic thing, right? Where you heat it up with a torch and it drips the solder and it's done.
Well, you use a air gun, you know. That you
Okay.
control the temperature with, so it's really, I've just used on very fine wires and stuff.
I understand.
Connections to, you know, a device or something like that, where they give you these little plugs like that, et cetera. And you can't buy a crimp thing that, you know, is manufactured for that smaller wire. So then you're left,
Well,
you know, what are your options?
Must have,
Yes, I do.
a little European terminal
What, hold on, what do you got?
And so these are just nice. 'Cause you
for
just
the smaller 22, 24 gauge, getting down like pretty small. I would take them, I would strip them out pretty good. I'd twist them up, then I'd solder them together or bend them in half to make them a little bigger, then solder them, and then I put them in this European terminal connector. That's what they use on European boats. And you can tag it into that, and if it's in a dry location, that's reasonable. So that's, you know, there are many paths to success, right? Just trying to do the work so it's gonna last as long as possible and not fail, so you have to call an electrician is the goal. And that's a decent way to do that.
And using ferrules versus bare wires when you make connections and things like that.
You know, I've had a lot of luck with them, and in some areas I don't like doing it because I've seen the wire pull out of the ferrule after it's been in the terminal connector.
Yeah.
So the crimper that uses the ferrule has 4 teeth that come on it, but I'm underwhelmed with what I've seen in the field of it pulling out of the ferrule. So the ferrule's got the screw clamping on it, and there is a spec where they don't want the screw like that's in that terminal connector there bearing down on the wire because it would break the wire. And I think that's kind of from when they were using solid wire. And one of the reasons that the wire is stranded is it's going to have less of a tendency to break and part. But I have that. I use that when it's required, but I don't prefer it. I'd rather have the end of the wire, like if it's smaller than even that, strip it over a little more, bend it in half and twist it, and then jack it in. So it's got a little bit more of an outside diameter to take the pressure of that screw. But again, you're not going to get in trouble for using a ferrule. That's a more professional way to do it for like more you know, computer kind of stuff, things like that I've seen, but it wouldn't be useful in battery connections. So, but a good point, thanks. Where are we? Okay, top 10 requirements for small boat owners is the color coding of the wires. You know, that's really important. You'll notice when you go to fisheries and you buy the negative cable, you have an opportunity to buy it in yellow. They changed that, I don't know, 15, maybe 20 years ago. The reason why they changed that is there was a very sad case. I think it was a kind of a party boat in Tahoe. Guy was putting his own inverter. The black cable for the DC ground is black. The ungrounded AC cable, that's the one that could kill you, is black. And the guy mixed them up. He put his inverter in. His family was swimming around the boat when he was working on the boat. He came up from the engine room and they were all floating in the water. It's called ESD, electric shock drowning. And they don't keep a record of how many people it happens to a year, but 0 would be my wish, you know? So they changed the wire color from black DC to yellow, not because of that one guy, but it happened enough times that, you know, why make the wires the same color? Because the inverter will get you.
So just make it clearly state, when do you use a yellow wire?
For AC.
As off, no, for DC. DC negative, yellow is the best color to use because it's not going to confuse someone else down the road that's just learning how to do electrical work, because the AC wires are black, green, and white. The white one is the neutral, the green is the grounding conductor, and the black is the ungrounded conductor. And that's the one, if you touch, it's going to bite you. So that guy mixed that wire up and he put it on the case ground of the inverter without shocking himself. But the case ground was connected to that grounding bus, which was connected to
But is
the.
this only in the context of an, I mean, like, I've got a boat that's full of red and black wires. There's not a yellow wire anywhere.
You're not going to change it.
Yeah.
Yeah, and you don't. It doesn't sound like you got a lot of AC on the boat, right?
No.
Okay, well, then it's not an issue. But it's the color coding that I was trying to touch on.
Is that the dragonfly?
No,
We already covered over current protection. You have a diesel on board, so you don't have to worry about a gasoline engine, but some of you guys you're talking about buying a gas boat, right? So anything in that engine room has to be ignition protected, even the bilge pump. For obvious reasons, right?
Yeah.
Gasoline's flash point, it will still explode at like negative 540 degrees. I mean, it can be that cold and you can get gasoline to flash off. It's a much more dangerous fuel than diesel. So that's why they want that stuff ignition protected in the engine room. Battery securing, battery should take 90 pounds of force in any direction. And we want that to happen, especially on sailboats. You guys don't have that big a deal with the multi-hulls, but the mono-hulls, if that's going upside down, you want that battery to stay very tight in the spot. Ways that I have done that, if it's possible, like sometimes the battery is, back in a location, is to build a UHMW or a starboard pad for it that's on top of the battery where you can still get to the terminals, and then build a post up to whatever is on top of it. So you've got it secured all the way around it, and then also from the top.
Compressed.
So if the boat does go upside down, the battery's not going to fall out of it and start banging around like a cannonball. So we good on time, or should I start wrapping this up?
I think you should start wrapping it up.
I have a question about ground, since you talked about it a little bit.
Okay.
So I got into a discussion with one of my friends who has a diesel inboard engine, and my boat was an outboard gas engine, and that's the only piece of metal in the entire boat that touches the water is the outboard. She was adamant that I needed to put in a grounding plate that grounded to the water, ground my system. Now, the boat came from the factory with none of that, but the boat's been modified since. Like the boat probably didn't come with an outboard motor that had a charging capability, electric start, and all that sort of stuff. So, do I need to ground the boat to the water, or is it just grounded back to the battery enough?
The boat is grounded to the water by the outboard, and you've got sacrificial anodes on the outboard.
Right.
Keep those, rolling
Right.
over your goodbye.
Thank you, Bob.
Oh, you're really welcome. It's really a pleasure to meet you. So you're talking about like a grounding plate in addition to the zinc anodes?
Exactly.
No, I don't think you need to do anything like that. No.
I have one more question.
Oh, hold on, no. Well, if we're just we're sailing along, we're running a bunch of electronic stuff.
Right, and the outboard's out of the
And
water.
the outboard's out of the water at that
Yeah.
point, so. Does it
I
need to
think she's
be,
talking about corrosion probably is for having ground effect.
is she talking about corrosion?
She's tying things together.
Yeah, the discussion was ground boat. That's
And-
what she was saying.
And what that comes from is if you have AC stuff on the boat,
Mhm.
there's a toaster in the galley. There's an internal part of the toaster that goes right to the case that has got AC from the inverter, which I know this is probably a scenario that doesn't happen on boats this size. That green wire is supposed to be grounded to the black DC ground. So that goes out the hull instead of into somebody who touches the toaster.
Okay, so let's say you don't have the inverter in the picture, but you
Right.
have shore power. Comes in on its own circuit. Goes to outlets in the boat. Does that does that AC ground need to go to your DC ground as well?
In one spot, yeah, and that's why.
Okay.
So
And then where does the DC ground go? Does it go into the water?
no, it's not going to the water, but it's got a path to the water via the outboard.
But if the outboard is up.
But we sail with the outboards up.
Oh, but
the
you wouldn't be
AC is not
sailing if
plugged
you're
in.
plugged in, yeah.
You know, I'm sure that.
Right, you're not on shore power at that
Yeah.
point.
I don't, that's an unusual circumstance that I'm having to think about, because if the outboard's out of the water, you don't have anything in the water.
Mhm.
So everything that's happened on the boat with AC, you're kind of on your own there. You don't have a path for that direct short to get down to the water.
But the only way it would go back would be out the grounding or the neutral line on the AC. It would go out.
But if the boat's not plugged in, you don't have that path.
Right, but
So,
then there's no AC on the boat, because it's not plugged in.
Right,
Yeah, kind of a riddle.
Well, unless
Goes
you have
around
an
and around.
inverter.
Unless you had the inverter run.
Well, right, it didn't have, don't have an inverter, so
Right.
that's out of the picture, but,
Hmm.
I had one other unique grounding scenario, I don't know if other people have questions. but-
Well, I'm trying to think about that last question
Yeah.
because typically the DC ground is grounded with bonding system. So on most of the boats I work on, that would be going out the shaft of the prop.
Right.
Because that's connected to the grounding system. But in y'all's scenario, there's
Don't have
nothing touching the water.
Mhm.
That's interesting. I gotta think about that.
Okay.
What was your next question? What was your next puzzle for
The
me?
next one, so we did just redo our complete electrical system from the panel to the battery. And it comes with, a bunch of lithium batteries, it comes to the starting battery. And specifically, the motor has charging, goes into a little battery, and I go through a DC-DC charger. And that DC-DC Orion TR charger has an isolated version or a non-isolated version. I chose the isolated version. My theory was that it kept the system that the motor was in with its little battery separate from the whole rest of the house battery system.
Which is lithium ion.
Yeah, they're
And
actually
you're-
both lithium, but yes,
Really?
yeah.
Well, why use the DC to DC charger?
Well, that's what, that was part of the question was, is there an advantage to the isolated system versus the non-isolated system? In that case,
I can't think of an advantage of using a DC to DC charger. Since you've got the same chemistry on both batteries, you're gonna get more charging with an automatic charging relay.
Okay.
Which is just gonna sniff that.
they are both
13.5.
lithiums, one's a different brand, one likes a different charge state than the other, so there's one likes 14.6, the other one likes 14.2 as a max charge.
Huh,
So
interesting.
anyways, even if I wanted, and actually that system on the motor started with an AGM that little spot. So. That's
why
I
did you
chose
change
that.
it?
Yeah, yeah.
Why did you change?
Just-
it from,
I've just
the-
added
the-
an
the
AGM.
lithium
Oh,
ion
if
and
you
then
want to
to
get in the whole system rechange, we can get into that, but I was just. Yeah, there's the difference between the isolated system, the isolated ground versus common ground.
Yeah, I'm sorry, I can't speak in depth of
Okay.
that. I mean, I would get the isolated one. It's more expensive and go for that, but.
Ultimately, that's what I did because I didn't understand.
Circling back on that, I was working with Vince on a problem like that. What is your alternator putting out? Because that's not meeting the profile of the lithium ions profile that it wants. But it's feeding that DC DC charger and you've got that programmed to feed into the house bank exactly what it wants, right?
Yep.
So we were trying to work with the manufacturer of the outboard that Vince brought, like, can I do an off-board regulator on that little alternator to make it exactly what the lithium ion battery wants? And that way you could, if you wanted to have two batteries, you just got a charging relay, which I think are really slick because that just drops the hammer. And all of the amps that are being delivered from that alternator are going to start and the house band.
Right.
With the DC to DC charger, typically they're like, what, 7 amps?
7,
10 amps
That's all
tops?
the motor's putting out anyway.
True.
Yeah, but the big, the big issue with the DC to DC, the reason for doing it is that you remove the risk that the lithium battery BMS shuts down because it's full, makes a decision to shut off the charging, and that causes that momentary or that instantaneous drop in the
Spike the
charging
alternator.
capacity causes the spike in the voltage in the
And you blow the diodes.
and
on
you
the
blow the
alternator.
diodes and what have you in your regulator rectifier.
They make a little zap stopper for that, which is just a
Wow.
cushion
Okay, yeah,
to stop that.
yeah.
But you make a good point that the challenges that we're seeing with the new technology with the lithium make me wonder if they're worth it sometimes, because you do have to do another couple layers of safety on it because the BMS can stop all charging, which would be the same thing as someone turning a battery switch off.
You know, and the other thing is you get into all this stuff, you find a lot of the stuff that is made theoretically to work doesn't work with the outboards as well because space constraints or other constraints. You know, I was looking at the zap stopper and realized, oh my God, I have to do this and this.
You can't get at the bits that.
So does your outboard alternator have an external regulator where you can have it
No.
configured
No,
for the lithium ion?
internal- So this has just happened to me. The thing I've just got through fixing is replacing the regulator rectifier component on the outboard,
Mhm.
because I believe it's faulty. I was getting 17 volts from when charging, but I believe that the cause of that was the fact that I had these lithium ion batteries that were in an at the time unannounced, undeclared manner, were shutting down their charging circuits when they determined that they were full.
Well, let me ask you, is the alternator on the outboard wired straight to the lithium ion?
Yes.
Okay, so that's the problem we're
Well, which
finding.
is I've just fixed by putting an AGM into that circuit.
Okay,
To buffer better, just like
right.
you and I
right.
talked about on my
I
system.
think that you're not getting regulated output, your outboard though, right? Like we would on another engine that has an alternator that.
It's got an internal regulator in it.
No, it does.
It's been a long time, and I want to respect everybody's time.
Yeah.
Here, so, because it is 8:32, and I know I've got people on Zoom, and I
Yeah,
still have a job in the morning, I'm not retired yet, so.
so, Bob, can we hold you for a few minutes for questions? We got some maniacs here.
I don't know, she's in charge. Should we stay?
Let's cut off our.
Questions from Zoom really quick before we end. Does anyone on that end have any questions? All right, cool.
Okay, well, I want to show you this because I didn't get into this. This is a labeler
That was.
and it labels shrink tube. So this doesn't just spit out labels, it spits out shrink tube that you can put on a wire and shrink down. So that's the coolest way to label both ends of the wire, to write what it does. So when I walk into a boat and I see both ends of the wire labeled with shrink tube with labels on it, I catch my breath.
So that's like $10, one of those.